All right, if you have any questions about stuff from this module, the Amazon module, it would be the time to ask. Of course, if you really want to go back and ask about Facebook module stuff, you can, but clearly that won't be the emphasis of the exam. So, anything you'd like me to revisit? Yeah. Okay. What would you, is there a more specific question? Okay. Well, I'll give you the brief one because, you know, recommender systems really are a whole lecture. So, all right. Okay, so where you probably are familiar with recommender systems is Amazon's people who bought this also bought that, right? That's the thing. So Amazon uses that because, you know, they're hoping to drive some sales, whatever. But more generally, recommender systems work like this. We don't know much about you, but we do know that you are, in some sense, like these other people. So we hope that you will like the same things they like. Okay? So the way that works for Amazon, you look at some product, right? They don't know who you are necessarily, right? You could just be some rando who hasn't signed in yet, you know, on a private browser tab, whatever. The recommender system is still going to work because all they're going off of is what they know about you, and what they know about you is that you're looking at this product. Well, they have a bunch of other people that in their history have also looked at that product, and they can show you things like, here are some things those people have bought, or here are some other products those people have looked at. Okay, this works out with other systems too that are delivering, other systems delivering some kind of ranked data, like for example, Google search results, right? They don't know exactly what you're looking for, and there's a lot of search terms where you could plausibly, you know, look at a lot of different topics, right? Or a lot of different web pages. But what they do know is that other people in the past have looked at some set of web pages, and they're basically show you that same set of web pages and hope that you're enough like those other people that those web pages are close enough to what you're looking for. Okay, that's recommender systems. And if you decide to become an IDS major and take some 400 level courses in the kind of math behind that, that collaborative filtering, by all means, you know, you can learn the math behind it. But for IDS 200, obviously you don't. Okay. Next thing. Yeah. Okay. So the three measures are support, lift, confidence, and lift. I'll do them in order, same order as the slides. Okay. So support is just how often two items are purchased together. Okay, so if 20% of McDonald's sales are for a, I don't know, Big Mac and fries, then that pair has 20% support. Okay? So that's what support is how often something is happening. And support is important because it's just going to show you your most popular product combinations. I mean, it's great if you have some products that are very popular together, but if, suppose like a lot of customers coming into your store who buy a fillet of fish also buy an apple pie. But if hardly anybody's buying a fillet of fish, it doesn't matter that much, right? And it's not something you're going to want to spend a lot of money on advertising about. Sure, it's something the organization wants to be aware of, But if 20% of your people are coming into McDonald's to buy a burger and fries, you want to implement that into all your operations. You want to gear your operations toward that combo. You want to have advertisers showing people, eating a burger and fries. Okay, that sort of stuff. So support is basically just a popularity metric. Second one, confidence. Confidence is how likely a customer is to buy product, I would say product Y, given that they bought product X. Okay? So suppose, let's see, who will say 40% of customers who buy a Big Mac, let's make it higher, let's say 80%, that's fine, seems more realistic, also buy fries, okay? Then the confidence that buy fries, given that bought Big Mac, is 80%, okay? 80% of the people who bought a Big Mac go on to buy fries. That's great. Now, the final question, lift. Lift basically tells whether confidence is greater, less than, or I should say greater than, less than, or about equal to average. So if 80% of McDonald's customers, right, all of them buy fries, then the Big Mac confidence number doesn't seem so important, right? If 80% of all your customers are buying fries, then the fact that 80% of them who buy a Big Mac also buy fries, it's like, yeah, whatever, it's about what I'd expect, okay? On the other hand, if only 40% of McDonald's customers buy fries, then lift is 80%, right? The actual confidence divided by 40%, right, which is the baseline, equals 2, meaning a Big Mac customer is twice as likely to buy fries as an average customer. Okay, so confidence shows you what product pairs are likely to be bought together, right? Support just tells you how often product pairs are bought. But confidence is about, if you bought this, did you also buy this? Like you might have a grocery store where a lot of people come in to buy milk and bread just because a lot of people buy milk and bread. And so you might see fairly high support for that. But confidence might not be especially high, right? It just might be, well, a lot of customers come to the store to buy bread and milk. It's not particularly more or less likely that they buy one or the other because of that. But if you have something like, I don't know, say coffee and coffee creamer that maybe people are buying at the same time, you might see that that's not very high support. Maybe only a couple % of your customers are buying both, but when they buy one, they tend to buy the other. And so they could have very high confidence, okay? And then lift just tells you, is this confidence higher than you would expect just based on random chance? Okay, cool, is that good? All right, so that's those. What else?
Could you go over the two-phase commit transaction model?
Oh, okay, that takes me back. Yeah, sure. I'm going to lift the picture from the slides, though. There we go. Okay. It's about slide 20, right? There we go. Okay. All right. So why do we do two-phase commit? What makes two-phase commit important and advisable and a good idea? Why do we have it? All right. Well, let's take a step back, right? Because I know people are always tempted to just learn terms and definitions, and they'll say stuff like, "This is the two-phase commit model. It has these two phases. It has this sequence," stuff like that. Okay. But that's not necessarily much in the way of learning. So I'm going to give you a baseball example. Who here is familiar with the game of baseball? Reason you are? Okay. So you know there's a position called a shortstop. Right. So in a terms and definitions type course, the question might be, what is a shortstop? Is a shortstop a real position? Where is the shortstop? Is it out in left field? Is it between first and second base? Is it between home plate and first base? That would be crazy. It's not there, right? Shortstop is, of course, between second and third. All right, trust me, second and third. Okay. Shortstop is between second and third. And the question that's deeper knowledge, why do you need a shortstop? Why is it not sufficient to have just a first, second, and third base? Why do you have an extra player between second and third base?
Because the ball goes there sometimes when it gets hit.
Yes. Why does the ball go there sometimes when it's hit? See? Deeper knowledge, though. Yeah, go ahead.
Because most batters are right-handed.
Yes, they stand on the left side of the plate, so when they swing, it tends to arc to the left, right? To the left of the batter, meaning it's going to go into that gap between second and third a lot more often than it goes into the gap between first and second. So you have an extra infielder out there, and that's why. And if you understand that, you understand a lot more than if you're just memorizing terms and definitions, right? So again, I talk about two-phase transaction model, right? Two-phase commit. Really, the important thing is why we're doing it and a rough idea of how it works. You know, not all these little details about what is a transaction coordinator, what is a resource manager. If you know why you have it and how it works, you kind of automatically know what transaction coordinator and resource managers are. And you'll have an idea of what the prepare phase and the commit phase are. All right. So anyway, onward with the answer. I applaud everyone who is brave enough to participate. All right. So your transaction coordinator basically is the software agent where their transaction starts. Okay. Your resource managers are software agents managing a set of one or more databases. And software agent, we just mean an application. Okay. Software agent's kind of a weird, scary term, but it's an application that does this. So the first thing that happens when a transaction comes through is the TC tells the RMs to get ready to do the transaction. Okay, there's a transaction coming through, you got to get ready to do it. The resource managers, RMs, tell their databases to pencil in changes and also prepare rollback records. Okay? When all DBs have confirmed, right, that they've done this, their RM responds to the TC and says, we're ready to go, right? And all the RMs got to do that before you can get to the next step. So when all resource managers have confirmed, the transaction coordinator knows that, number one, everyone is prepared, and two, recovery is possible, right? If something goes wrong, everybody's got their rollback record so they can restore the system. If not all RMs confirm, or some just say nope, the TC will abort the transaction, right? It won't happen. Won't happen until they're all pointing in the same direction, right? Until they're all ready to go. But once the TC is heard back, then TC tells the RMs to make the transaction permanent, right? Basically do this thing. Okay. And so RMs tell their databases to make the changes permanent. Okay, once again, when all databases have confirmed, their RM responds to the TC. Okay? Okay. Then once again, when all resource managers have confirmed, the TC knows the transaction succeeded, right? If not all resources managers respond back, then again, the transaction is canceled. Rollback records are used to restore the system. Once the transaction has been done for a while, eventually the rollback records will be discarded. Okay? And the whole point of this two-phase commit, remember, at the end, you want to make sure that all of these different databases that might be involved in the transaction, they're all going to point in the same direction. They're either all going to say the transaction succeeded, or they're all going to say the transaction failed. You don't want to have the case happen where some of the databases think it succeeded and some think it's failed, because then things are going to go horribly wrong, right? You'll have your supply chain system looking for a shipment that isn't there. You'll have the credit card company getting paid for items that were never shipped, whatever. Things go horribly wrong. Okay? That's two-phase commit. All right, other stuff. Yeah. Okay. All right. So S3 is Amazon Simple Storage, which is basically used for storing large amounts of data, right? So terabytes. And number two, running analytics on that data. Okay, so a lot of organizations, if you have a standard ordinary machine, you might have, these days it might go up to like 64 gigs of RAM. And, something like maybe 3/4 of that might be available for analytics type stuff. But if you have terabytes of data, you're going to have to build a special kind of dedicated system to do number crunching on that volume of data, which a lot of businesses don't want to do. They don't want to be IT businesses. They want to make cars or sell shoes or process photos, whatever. So it's very nice that Amazon says, yes, you can store your large amounts of data with us. And then if you want to run queries on it, you can run queries on it without downloading that data first. That's S3. Or at least that's S3 as you need to know it for IDS 200. EC2 is Elastic Cloud. Basically, hosting applications, right? And some data storage, right? But the main focus of EC2 is you want to run your applications in the cloud. Hosting applications, maybe transaction processing, things like that. Anything you want to do in the cloud through Amazon that you don't want to have to manage under your own roof. So a good example of that would be something like Intuit. The Intuit case I talked about, because they're a tax service. Tax services are only busy part of the year. So instead of having all that hardware under their own roof that's going to be gathering dust for like 10 months out of the year, they run those same applications on hardware they rent from Amazon, run those applications in the cloud. And then the 10 months of a year that it isn't busy, well, they don't have to pay very much. That's EC2. Okay, so different systems for different purposes. Just like you wouldn't run applications in the same kind of memory that you would store lots of data on, you don't have the same system in the cloud that's more for storage and use it for the same running applications. If you'd like to think about it this way, EC2 is more like RAM and S3 is more like a hard drive. If you want to think about it that way, which again is a simplification, of course, but it's close enough to true. All right, what else we got? Yeah. Yes. All right. So before we talk about N tier, I'm going to talk about client server because obviously that's somewhat essential to understanding. Okay, so client server going to look something like this. All right, it's going to look like an alien from like an early 80s video game. Okay, so these are the clients down below. Here's the server, and perhaps the server itself has a few connections to a few pieces of database hardware. Okay, but the important thing to remember is this. A server only has so many ports, right? Just like your laptop only has so many USB ports, and sometimes you wish it had more. Server's only got so many ports too. It can only support so many clients and so many connections to so many database machines. Now, if everything you want to do can be kept on that server in those few databases, it's fine. Okay, so if everything you need can be reached, client server, I'll do it, is fine. Okay, problem happens with scale. Imagine you're an organization like Facebook that has literally exabytes of photo data. Well, there's no way you're going to be able to store that much photo data because, you know, 1,000,000 terabyte hard drives, you'd literally need 1,000,000 different ports on your server. And servers, you know, might have a few dozen ports, but you're not going to connect it to 1,000,000 database machines. And they'll all have to be separately connected to this one and not connected, you know, or copies connected to other ones. It's a huge headache. You don't want to do that. So as you have a lot more data, you're going to need to have, you know, clients accessing the data in a different way. Same thing, but lesser concern. Usually data is the bottleneck that you hit first. But also if your server can't run all the applications that you want to have, right? Suppose you have too many applications under your roof and users have to say, well, this server can't handle all these applications running at different times. So if I want to use a different application, I have to actually get up out of my chair and go to a different workstation where that application is available. Again, kind of a headache because you can switch these connections, but switching those connections is fundamentally manual. You unplug some cable from a port and you plug it into some other device. You don't really want to have to do that. All right, so client N tier though, okay, clients connect to servers through an interface, and we're going to flip this around in just a second. There we go. Boom. Okay, so any client who connects to the system, they're not directly connecting to a single server machine. They connect to the interface, and the interface guides them to whatever server it's appropriate for them to be on. Just like you go to facebook.com, you don't connect to a specific server in Facebook. You don't tell Facebook, hey, connect me to server number 3642. You just go to facebook.com, and through that interface, Facebook decides what server you go to. Likewise, these servers themselves have an interface with all the many database machines in the back. All right, so all these servers themselves can do the same thing. They can also connect with you. All right, good enough. Same kind of thing, right? You don't want your servers to be bound to connected be connected to a single database or a small set of databases. For something like Facebook, when you're going to Facebook, you need to be able to access all different kinds of database hardware, because 1 second you could be looking at your friend's vacation photos from last week, and then the next second you could be going back to look at pictures of your dog from 2009, right? It bounces around that fast. So this over here is N tier, and again, excuse me, it basically solves the scalability problems of client server. Client server works fine as long as everything you need can be there on that machine or immediately reached by it. But as the system gets bigger, and in particular, as the amount of data gets bigger, you need something like N tier to allow people to very easily and flexibly connect from different devices to other devices. That's N tier. And N tier and its descendants are still widely used today. This is like the core networking technique. I mean, your big cloud systems, they've built some layers onto this. That's why they say N tier, where, you know, we talk about this 3-tier system. There's other ones with more tiers that have things like how applications are assigned to which machines and stuff like that. But this core model here is pretty much true. All right, what else? What else we got? Yeah.
Can you talk about the requirements for the cloud?
Yeah, okay. I didn't really, let's see how many I can retrieve from memory. All right, so when I say requirements, right, requirements for a viable, popular cloud service, right, one that people are going to show up and and use and be happy about using. So certainly, elastic leasing, right, can be changed rather quickly. Over the internet, that's another thing. What else? Metered, right? Or pay as you go, right? Which is a common thing. Let me think. I'm coming up a blank on these other couple things. I know there's 5. Shared resources was one of them. What's the 5th one? I was going to say elevated security. I mean, obviously you need that, but I don't think that's one of the ones that's listed. Let's see. Service-based, okay, yeah. And service-based. Okay, and service-based, I will basically say to allow flexible deployment and selection of various application modules. Basically, the pieces of your system that you're deploying in the cloud can put the busier ones on, higher grade parts of its technology. The ones that are less busy, it can put in lower grade ones and save you time and money. Once again, it's like caching. If you have some aspect of your system that's very busy, your cloud wants to keep that in RAM so it can serve it up very quickly to your users and make your users happy. If there's some data that is not very busy, gets looked at like once every 5 years, if at all, there's no point keeping that in RAM because RAM's a lot more expensive than disk storage. All right, so that's a simple one. Okay. Did you want me to elaborate on any of these more than I have? I think that's, yeah, cool. Okay. Yeah.
Can you go over the differences between the different cloud service models?
Okay. Sure. Again, this is just a recap of what I did before. So, infrastructure as a service, or IaaS. Okay, basically, you get to use their machines. You are responsible for installing and maintaining all software, even operating systems. So the short version there, maximum flexibility, right? You can do anything, but also maximum management headaches, because that's all that work you got to do yourself. That's infrastructure as a service. Now, platform as a service, let's do that Blue, sure. Oh, you know what? I'll do it in dark blue. Okay. Huh. You know, this reminds me of a funny thing back when I was a TA for IDS 495, like 20 years ago. There was one student who turned in a term paper, and it was very unfortunate because, at one jarring juncture in the paper, she went from, having not very good English to suddenly like, Harvard level English. It was like, it was beautiful prose and it flowed and whatever else you want to say. And that alone was suspicious and obviously would have triggered some stuff. But the real thing that she missed was when she copied and pasted that text into her paper, she didn't notice that text, that whole slug of text was actually in dark blue and not black. Yeah, it's quite easy for me to find the content on a web page. And yeah, just thought of that because, black and blue here we are. Okay, so platform as a service, you get the machines like infrastructure plus OS plus operating systems and maybe basic apps, right? Like maybe a vanilla database or some analytics tools. Okay, you'll get stuff like that. You're not going to get super fancy stuff. You're not going to get very specific stuff. But yeah, depending on the organization that you're getting the service from, they might throw that in. And again, the example I toss out is Oracle. Oracle is big in the world of relational databases. If you're going to Oracle, you're going there because you want to use relational databases. So they just kind of throw that into the package. All right. And again, good if you want to use custom apps, but don't want other headaches. Okay, you don't want to mess with installing, maintaining whatever operating systems. But yeah, if you have your own applications, it's worth considering platform as a service. Okay. And the last one, software as a service. Okay, software as a service, you get the platform, like platform as a service. I gotta make this a little bigger. And you get to use the apps that are already there. Okay, so again, overall, not much flexibility, but very easy to use, right? Just show up. All right, the downside, of course, of software as a service is what's there is there. Either if you develop some new business needs that you did not previously have, you might have to switch services at that point, right? If they don't have something that you really need. But that's the three. Okay. What else? Yeah.
Can you talk more about standard re-engineering sequence and business processing?
Well, I mean, I wouldn't get super formal about that, but sure. What you should do for BPR, right? First of all, you should map out the process. Okay, understand what the process is. And again, in a well-managed organization, this should already be done. But whatever, maybe it hasn't been, or maybe there have been some changes and you need to check that out. Okay, then next thing, look at the process and identify bottlenecks, right? Areas that need improvement. We'll talk about this case for Amazon in just a second. Then brainstorm some solutions, right? Just come up with some ideas. What might you try to do to solve this problem? Eventually, you will need to try an actual solution and see how it works, and then try to improve it further, or quit and try something else. Right now, again, if I decided on Sunday to break this class up into groups of 4 and come up with a sensible approach to modifying an existing business process, you would all come up with something pretty close to this, right? You'd have 3 steps, maybe you'd have 4, but the basic idea of look at the process, figure out the problems, come up with some solutions is not rocket surgery. So, but I'll talk about how it worked out for Amazon. So again, for Amazon back in the day, they had their process. Customers visit site, search for books, find what they want, then buy. Okay, that's the ideal way it was supposed to work. But what Amazon noticed, areas that need improvement, many customers abandon the search process. And Amazon said, wow, that's, crazy and unfortunate. We've made so many books available to people, they can't find one that they like. But the problem is there were just so many results, it was kind of overwhelming for a lot of people. And they're like, oh, I don't know, I just really want to look at the covers, whatever. So they brainstormed some solutions, right? They locked a bunch of smart dudes in a room and they said, you're not getting out of here until you've got 5 good ideas. And then they came up with 5 good ideas. One of them was the recommender system. So implemented the recommender system and improved it in the following years. Basically, that's it, right? So the recommender system that Amazon has, they said this is a good starting point, and the recommendations are only going to get better as we have more data. Right? Now, obviously, implementing the recommender system itself into the web pages and into their other systems, that had further snowballing consequences we talked about, but this is where it starts. Okay. Anything else? Nothing? All right, going once. Going twice. Oh, wait, before you go, I have 2 things I want to say. Number one, students vastly overestimate how interested professors are in the grades they get. I mean, I wish you all well, especially those of you who actually attend lecture sessions. But, starting off an email with, hey, professor, I really want to get an A, is just going to make your professor roll his or her eyes. They're going to be like, oh, one of those students. If you really wanted an A, you should study hard enough to get the A, because that's how that's supposed to work. Number 2, retests don't happen. And some professors have a different philosophy on this, right? Some professors will say, okay, if you didn't learn it first time around, fine, I'll give you another chance to do a retest. In my opinion, that makes sense in elementary school, right? If it's 2nd grade and you didn't learn to read great halfway through 1st grade, you know what? You got 4.5 more years to learn. But something like this, something technology, it's like you have an interview at some point. At some point, what you know is what you know, and you're not going to get a re-interview if you bomb the first one. So I want to try to encourage people to absorb the knowledge well up front. That's all. That's why I do what I do. Okay, that's all. Off my soapbox. Have a good time. I'll see you all on Friday.